Let's go!
As a developer of any experience, you probably had similar feelings while working on a bad codebase. Trying to solve rather simple tasks in such a codebase sends you circling around the editor as well as in your head. Things that should take you minutes, you spend days or even weeks on. Estimation of tasks is impossible and feels like playing the lottery. But even though it is quite easy to spot messy and bad code from good code, it is far from easy to create good code. As you might agree that bad code slows us down, we need to learn what actually can be regarded as good code. And this is where Uncle Bob and Clean Code come to our help. He and the other authors of the book say that good code is clean code. Clean code in turn means that you make the code as readable as possible. This makes a lot of sense, since you will read code many times more than you will write it. Recognizing good code is therefore the promise of this book. It even promises an intuition for cleanliness of code, a so-called code sense. But the authors are also direct about it. This will be hard work and it will take lots of practice. Besides learning about the different aspects that make code readable, you also need to learn how to apply them to your own code. A good example for readability from the world of real things is a newspaper. That's the reason why Uncle Bob argues that clean code should be as easy and as intuitive to read like a newspaper. A newspaper groups sections to belong together. One group might be international news, another might be economics, and so on and so forth. So you should organize your codebase in a similar fashion. You should group modules, packages, and assemblies in a way that they belong together, either based on functionality or on domain concepts. To find what you want to read in a specific section of the newspaper, you simply scan the headlines. In our codebase, classes represent those articles, and the headlines are the names of those classes. This means our class names should reveal their intention. Then, by looking at it, you can decide if you are interested in it right now. The synopsis of the article you are interested in gives you the most important information at the top of the article. And a class usually has a public-facing API, exposed by its public members. This is our synopsis of the class. As a reader, you can now understand on a high level what the class is about and decide if you are interested in it right now. An article that is interesting to you can be read from top to bottom. With each paragraph, the details are pouring in. Each paragraph has its own little headline giving away its details. For our class, these paragraphs are the private methods of the class. The name, like the paragraph's headline, tells us what it does. And the body of the method does the actual work, the implementation details. So, now we have an image of how our code should look like on a high level. We now need to look at the rules for the details. The book uses Java as the language of choice, but the rules can be used for any other language too. Think of all these rules as a sort of guideline. They are neither gospel, nor do they apply in all cases. But when applied as often as possible, they tend to help you to achieve good results. These rules help to think about the readability of your code with a framework in mind, which is the most important aspect to these rules. Functions are the most common building blocks of any code base. To make them as readable as possible, we want to use names that tell us exactly what the function does. The names should be as long as they need to be to describe to the reader what the function actually does. This is also true for the arguments and variables inside of a function. With this in mind, the actual work of any function should be focused on exactly one thing that it does well. This includes that every function should only allow one level of abstraction. So for example, if you are calling the database, no business logic must exist in the same function. The last hard and fast rule for functions follows from the other rules. All functions should be as small as possible. This means the function should have as few statements as necessary to fulfill its single focus. It also includes the amount of arguments. It is best for a function to have no arguments at all. The next best is 1 or at most 2 arguments. Anything above that is a huge smell, according to Uncle Bob. Most programming languages deal with objects nowadays. Naturally, we also get some rules for the classes. Each class should commit to a single thing that it does well. Sounds familiar to functions, right? This is also known as the single responsibility principle. Like with functions, we want to have the name reflect the intention of the class. Classes should also be small. Not as small as a single function though, but with the single responsibility principle in mind, we should strive for classes that are as small as possible. As the next block of rules, the book spends a lot of time on naming, formatting, and comments. These are essentials that are often overlooked when it comes to readability. The rules for comments simply state that instead of describing what the code does, they should explain why this code exists. The formatting rules we already discussed somewhat with the newspaper analogy. Uncle Bob argues that you must group cohesive statements and separate them from other groups by vertical spaces in the code. Think of line breaks, for example. The same is true for the vertical ordering. The top statement should be on a high level of abstraction and more important to the understanding of the function or the class. The last and seemingly obvious thing is indentation. Without it, any program would be virtually unreadable for any human being. So we need some rules for this, but they often depend on the language conventions itself, so we don't touch them in this video. Formatting is way too important to neglect, but it's also way too important to be religious about. That is why you and your team should form some guidelines around this. And the guidelines from this book are a good place to start. And to follow these rules in your day-to-day work as a developer, you have to practice a lot. And the book gives you opportunity to do so by refactoring existing code with these rules in mind. For more about the book's contents, click on the link in the description. You will find a one-page summary, all rules from the book as a single PDF file, and much more as a downloadable PDF. So as the core messages of the book, I took the following. Clean code is of vital importance for almost every software project out there. The most important measure of clean code is the readability of the code itself. You can achieve readability by structuring your code in a way that it reads like a newspaper, which leaves you with all the important information at your fingertips at all times. If you apply the specific rules for functions, classes, and so on, you will end up with code that anyone will be able to read, understand, and reason about. I personally read the book some 10 years ago, and I quite liked it ever since. As the book states itself, you will probably be violently opposed to some of the rules stated in the book. So the rules and principles are absolutely not the end-all be-all, but they are a good start to improve the readability of your code considerably. I personally found it to be immensely helpful to guide my decisions and form my own set of rules over time. So therefore, I highly suggest to read this classic of software engineering, think about the ideas, and try to build them into your process of developing software for yourself.